Everyone, myself Abhishek Subrashet. I'm studying in first year MSc Chemistry in JSS College of Arts, Commerce and Science, Ooty Road, Mysore. In this session, I'm going to explain the solutions of Schrodinger wave equation for free particle and particle engineering. Let's begin with the topic Schrodinger wave equation for free particle. In Schrodinger wave equation of an atom, the energy states or the orbits proposed by Bohr is replaced by a mathematical wave function psi. Let us consider a simple wave equation as that of the vibration of a stretched string, that is dou square y by dou x square equal to 1 by u square into dou square y by dou t square. Here y is amplitude, x and t are variables, u is the velocity of the propagating wave. In order to solve this equation 1, we have to separate the variables, that is y is equals to f of x into g of t, where f of x is a function of coordinate x only and g of t is a function of t only. For stationary waves such as stretched string, the function g of t is represented by the expression g of t is equals to a into sine of 2 phi mu t, where mu is the vibrational frequency and a is a constant known as maximum amplitude. By substituting the value equation 3 in equation 2, we get y is equals to f of x into a sine 2 phi mu t. By doubly differentiating equation 4 with respect to t, we get dou square y by dou t square equal to minus f of x into 4 pi square mu square into a sine 2 phi mu t. By doubly differentiating equation 4 with respect to x, we get dou square y by dou x square equal to dou square divided by dou x square into f of x into g of t. Substituting equations 7 and 6 in equation 1, we get dou square f of x divided by dou x square is equals to minus 4 pi square mu square divided by u square into f of x. Here we know that vibration frequency mu is related with the velocity by the expression u is equals to v into lambda, where lambda is the corresponding wavelength. Hence equation 8 becomes dou square f of x divided by dou x square is equals to minus 4 pi square f of x divided by lambda square. This is for one dimensional. We can expand this into three dimensional. Then the equation becomes dou square psi by dou x square plus dou square psi by dou y square plus dou square psi by dou z square is equals to minus 4 pi square divided by lambda square into psi. We know that the de Broglie relationship is lambda is equals to h divided by mu. Substituting this in equation 10, we get dou square psi by dou x square plus dou square psi divided by dou y square plus dou square psi by dou z square is equals to minus 4 pi square m square u square divided by h square into psi. We know total energy of the particle is sum of the kinetic energy and potential energy. We know that kinetic energy of a particle is half mu square. Then the simplifying equation, we get m into u square is equals to 2 into e minus v. Substituting equation 12 in equation 11, we get dou square psi by dou x square plus dou square psi by dou y square plus dou square psi by dou z square plus 8 pi square m into e minus v psi divided by h square is equals to 0. This is the Schrodinger wave equation for free particle. This is also known as Schrodinger wave equation for time independent. Next, Schrodinger wave equation for particle engineering. Let us consider a particle of mass m rotating in a circle of radius r in the xy plane if the potential energy of the particle is 0. Let us consider a ring. It is two-dimensional. In this, the z coordinate is 0, so we can write the Hamiltonian operator as h cap is equals to minus h square divided by 8 pi square m into dou square by dou x square plus dou square by dou y square. Since the motion is circular, h cap is represented in polar coordinates, that is r comma theta or phi. The Cartesian coordinates x and y are related to the polar coordinates r and phi as x equal to r cos phi, y is equals to r sin phi, where phi is the angular variable, varies from 0 to 2 pi, and the radius r is constant. Then the Hamiltonian operator becomes h cap is equals to minus h square divided by 8 pi square into m into r square into dou square by dou phi square. Here m into r square is the moment of inertia, hence it can be replaced by I, that is minus h square divided by 8 pi square I into dou square divided by dou phi square. Representing in eigenfunction form, we can write minus h square divided by 8 pi square I into d square f divided by d phi square is equals to E into f. The solution for this equation is d square f divided by d phi square plus m square f is equals to 0, where m square is 8 pi square I into E divided by h square. By using this equation, we can find out the energy of a particle in a ring. Then the solution for the equation 1 is f is equals to n into sine of m phi, and f dash is equals to n dash cos m phi. F double dash is equals to a into exponential of plus or minus I into m phi. These equations are in trigonometric forms. These are also called circular harmonics. And equation 2 and 3 are equivalent in view of the theorem, that is exponential of plus or minus I m phi is equals to cos m phi plus or minus I into sin m phi, where equation 2 and 3 are finite continuous for all values of phi and m and single valued. Since the angles phi and phi plus 2 phi represent the same point, the property of the single value demands that f of phi is equals to f of phi plus 2 phi, sin m phi is equals to sin m into phi plus 2 pi, cos m phi is equals to cos m into phi plus 2 phi. This is possible only when the m value, when m takes the values 0, plus or minus 1, plus or minus 2, plus or minus 3, and so on. Similarly, a into exponential of im phi is equals to a into exponential of im into phi plus 2 phi, that is equals to a. We know that exponential of I into 2 pi m is equals to 1, or cos of 2 pi m plus I into sin 2 pi m is equals to 1. This is also possible only when m is equals to 0, plus or minus 1, plus or minus 2, plus or minus 3, so on. As regards the boundary condition, there is no barrier to the particle of a particle's motion as long as it is on the ring. So there is no condition for the wave function to vanish at any point. I referred the principle of physical chemistry for 48th edition, Puri Sharma and Patania, quantum chemistry by R.K. Prasad. I hope you understand. Thank you.